Hi folks, this video will explain the theory for this week on how to find distance from a speed-time graph, and it will also take you through some example problems. So on this screen, what you'll see is the ambulance will move across the bottom of the screen, and what we're going to focus on is the graph here in the middle. It says velocity at the top, we'll just call it speed, and you'll see that the graph has got speed in meters per second on the left hand side and time measured in seconds along the bottom. So we're going to start off by looking at the graph that we get when the ambulance is travelling at a constant speed. So you'll see the ambulance travelling across the bottom of the screen, and in the middle graph you'll see a blue line that goes horizontally across the graph, and that tells us straight away that the ambulance is travelling at a constant speed. Looking at the graph, we can see that the horizontal line lines up with 5 meters per second. So it's travelling at 5 meters per second for a total of 10 seconds. Now this week we are trying to find distance using a speed time graph, and this first example is pretty straightforward. So here's the graph that we got that describes the motion of the ambulance, a horizontal line because it's travelling at a constant speed. We can see from the graph that we've got 5 meters per second for the speed, we've got 10 seconds for the time of the journey. From your equation sheet, you all know now that distance equals speed times time. So here we've got a speed of 5 meters per second and the journey lasted for 10 seconds. So that gives us a total distance of 50 meters. So that one's pretty straightforward. However, if we were to look at the motion of the ambulance where it is accelerating, where it starts from rest at this left hand side and then begins to accelerate across the bottom of the screen. So if we show that now, you can see the ambulance starting from rest from the left and then gradually increasing its speed. As it increases its speed, you'll see that the shape of the graph this time isn't a horizontal line but is a diagonal line on the graph, and that tells us that the object is increasing its speed. We can see that it goes from 0 meters per second and reaches a final speed of 10 meters per second. And again, the time of the journey is 10 seconds. Now the problem that we've got with this graph, again, we can see the numbers from the wee animation. We start off at 0 meters per second. We have a final speed of 10 meters per second, and the time of the journey is 10 seconds. If we were to use the equation again, like we did in the first example, you would see that we've got a problem because we've got two speeds this time. We don't have a constant speed like last time where the speed wasn't changing. We've got this initial speed, which we gave the symbol last week as u, that's the initial speed. And we've got this speed at the end of the journey, which is v, the final speed. Now we can't put both numbers into this part of the equation. So when we work out the distance travelled using a speed time graph, we can't use the equation distance equals speed times time, because in some cases we don't have the object travelling at a constant speed. So to find the distance using a speed time graph, instead of using the equation, what we do to find the distance is we work out the area underneath the graph. Now in this example, because it's accelerating and we've got the diagonal line from 0 to 10, we've got a triangle shape underneath the line on the graph. For the example earlier, we can use the equation. If we were to work out the area, in this example we've got a rectangle. If we were to work out the area of the rectangle, it's the same equation that you use in maths. You would do the length times the breadth. That would give us the same two numbers that we used in the speed, distance, time equation. So that would be 50 metres as well. So both methods work when you've got a constant speed. But you're not always going to have a constant speed. So the best way of working out distance when you're given a graph is to always use distance equals area under the graph. And when you're asked to work out distance from a speed-time graph, this line here basically becomes your equation. So if you were doing calculations using equations, the first line would always be an equation and then you would substitute in the numbers. For these examples, when you're working out distance from a speed-time graph, this is your equation. This is your first line that you should write down for every single problem that you do. Now the ones for constant speed are pretty straightforward because as you can see they basically match the equation speed, distance, time. The ones that have acceleration and deceleration are a wee bit more tricky. So first of all, write down the first line, which is distance equals area under the graph. Now this time I've got a triangle. The area for a triangle is the same as you would do in maths, is a half times the base times the height. If you prefer to write down a half times length times breadth, so that it's kind of similar to the equation for a square or rectangle, then that's also fine as well. Both of these would be acceptable. So in this example, we would take a half, we would multiply it by the base, which would be along the x-axis for time, and we can see that the length of the triangle here would be 10. We would then look at the height of the triangle, and we would get that number from the y-axis over here, where we've got 10 metres per second. If you wanted, you could call that a half multiplied by 10 times 10, which is 100. And that would give you a final answer of 50 metres. So, the two important points is that your first line is this bit here, distance equals area under the graph. That is the first line that you write down for every problem where you're asked to find the distance from a speed-time graph. The second important point is even although they're asking you to work out area, the area is a representation of distance. In maths, area would be measured in metres squared or centimetres squared or something along those lines. But in physics, because the area represents the distance, you don't give your answer in metres squared or centimetres squared. Because it's distance that you're trying to find, the units would be metres. So even though you're calculating an area, the unit that you need in your final answer needs to be metres because the area represents the distance. Okay, so the problems that you're going to do this week, there are a couple of examples to show you how to work out the distance from a speed time graph. Here, we've kind of got a combination of the two graphs that I've just shown you a few minutes ago for the ambulance, but the same method is used for this one. So what you would do is we're looking for the distance travelled by the go-kart during the 20 seconds that are shown on the graph. Now you'll see here that they've split the graph into two parts. I'll just draw that dotted line down to show it as well. So what we've got is we've got area 1. And area 1 is the triangle. And then we've got this second area here on the right, which is a rectangle. Now the examples that I showed you earlier, the first was a rectangle, and you found the area of the rectangle, and that gave you the distance. The second example was for the ambulance accelerating, and it gave you a triangle underneath the line on the graph. So you worked out the area of the triangle. What's happening here is the go-kart is starting off at rest and it's accelerating for 8 seconds. And you can see that for those initial 8 seconds, it goes from 0 to 9 metres per second. So that gives us a triangle underneath the line on the graph for the first 8 seconds. But then you can see it reaches a constant speed and it stays at 9 metres per second for the remainder of the journey, from 8 seconds to 20 seconds. So what we're going to do for these examples, where we've got two shapes, is work out the area of each shape and then add them together to give us the total distance for our final answer. Okay, so you can see the numbers filled in for us already. If we focus on the triangle first, you can see they've written the formula, half times the base times the height. If you wanted to write that as a half times b times h, that's fine. If you also wanted to write a half times length times breadth, or L times B, that's also fine. And basically all we're doing is taking the numbers for the graph and substituting them into the equation. So the base of the triangle is from 0 seconds to 8 seconds. So 8 take away 0 gives us 8 for the base. For the height of the triangle, you can see it starts off from 0 metres per second and it reaches 9 metres per second. So 9 take away 0 gives us 9 metres per second for the height. 9 times 8 would be 72. If we times that by a half, that gives us 36 as the area of the triangle. Then we want to look at the area of the rectangle on the right hand side. The rectangle is, you could do b times h for base times height. You could also do L times B for length times breadth. Any of these would be acceptable. So first of all, we're looking for the base of the rectangle. Now you can see the rectangle starts here at 8 seconds and finishes over here at 20 seconds. Now the rectangle doesn't go from 0 to 20. What we need instead is the difference between 20 and 8. So 20 minus 8 gives us 12. So the base of the rectangle is 12. The height of the rectangle is easy to find because it's the same number we had before. It's a constant speed of 9 metres per second, so the height is just 9. And 9 twelves gives 108. Now the total distance, we would then add these two numbers together. So we get 36 plus 108, giving us 144 metres. Remember, it's not metres squared, because the area, although we're working out area, we are saying that area represents distance. So we're not given our answer in metres squared, but we're given our final answer in metres, because the area is representing the distance travelled. One last example, same idea again, only this time you can see the graph is split into 3. Now, if you just had a graph with one shape, you just find the area of that one shape and write your answer in metres and you're done. If you've got 2 shapes, find the area of each of the 2 shapes and add the 2 areas together and give your final answer for distance in metres. Here, we're taking it one step further because we've got 3 shapes this time. So there's no scale on this example. Only the key numbers have been included because this is just a sketch of a graph. So this might be easier to work out where the numbers come from rather than having to read a scale. You can see that they've labelled the 3 parts of the graph as area 1, area 2 and area 3. So for area 1, you'll be able to see that it's a triangle. So for a triangle, it is half times the base times the height, or you could write half times the length times the breadth, whatever one you prefer. We can see from this first triangle that the base is 10 and the height on the left hand side is 8. So for area 1, it's a half times 10 times 8. So 10 times 8 would give us 80. Half of that would give us 40. For area 2, we've got a rectangle. So for a rectangle or a square, it's just going to be L times B. Or if you want to do B times H, base times height, that's fine. So the base for this one, we start at 10 and we end at 40. So that means that this distance here will be the difference between 40 and 10, which is 30. The height of the rectangle is the same as the height of the triangle that we had for area 1, so it's just 8. So you can see for area 2, it's just 30 times 8, which is 240. And for the last section of the graph, you can see that we're back to having a triangle again. So that's going to be a half times base times height, or if you want, half times length times breadth. We can see the base this time, we start at 40 and we end at 50. So we're going to take the difference between those and we get 50 minus 40, which is 10. And then the height is the same as the other 2 areas, it's just 8 again. So for area 3, because it's a triangle, it's a half times 10 times 8. And it ends up working out as the same answer as area 1. 8 times 10 is 80, half of that is 40. So we've got our 3 areas all worked out. For area 1, the answer was 40. For area 2, it was 240. And for area 3, it was 40 again. So to get the total, we're just adding those numbers together. That gives us 320. So our total distance is 320 metres. So there's a few steps involved with that one, but the theory is pretty straightforward. You're just working out the area of each shape and then adding the answers together. What you must do for every question, the very first line that you write down for every problem is this bit here, distance equals area under graph. Okay, that's basically your equation for these problems. So you have to write that down as the first line for every single problem that you do. Now that you've watched this video, you can have a go at least a couple of the problems on each of these pages in this document.